All right, strap yourselves in because we're going deep today.
Diving into the world of flight dynamics.
You know it, and you sent over this,
That's what?
well, this simulation. It's called the
Oh, yeah.
Flight Dynamics Gimbal JavaScript HTML5 applet simulation model.
Catchy.
It is catchy.
Yeah.
And I'm pretty excited to get into it.
Yeah, it's really cool.
I gotta say.
It's a great visual.
Yeah.
It's a great way to visualize how aircraft move in 3D.
I mean, I know the basics, like
All right.
pitch, roll, and yaw.
The fundamentals.
But honestly, sometimes I get them all jumbled up in my head.
It happens.
Especially yaw and roll. They
Yeah.
both just seem like turning to me.
Well, they do both involve turning.
Right.
But they happen on different axes
Okay.
of the aircraft.
So, like, how's roll different from yaw, then?
So let's start with roll.
Okay.
Imagine you're holding your arms out like wings.
Okay, got it.
All right. And rolling is like when you tilt your body side to side,
Side to side, okay.
pivoting around a line, going from your nose to your toes.
Oh, okay, I see.
Yeah.
So if I'm picturing it right, if I was the plane rolling, rolling is what makes the wings dip up and down.
You got it.
Okay.
That's the movement you see when a plane banks into a turn.
Okay.
Now, yaw's a turning motion too,
Okay.
but it's more like shaking your head no.
Oh, okay.
It's rotation around that up and down axis, like a pole going right through your head.
So like a vertical axis.
Exactly.
So yaw is what changes which direction the nose is pointing, and
Yeah.
is more of like a horizontal turn.
You got it.
Got it.
And then pitch is probably the easiest one to imagine.
Okay.
Just like nodding your head, yes.
Up and down.
Imagine you're a pilot looking straight ahead, right at the horizon.
Okay.
Pitching up is like nodding up to the sky,
Okay.
and pitching down is nodding down to the ground.
Yeah.
Simple as that.
All right, so to recap,
Yeah.
pitch controls whether the nose is pointing up or down.
Yep.
Rolls is tilting the wings, and yaw is turning the nose left and right.
Bingo.
I think I'm finally getting it.
Good.
And so the simulation actually lets us mess around with all three.
It does.
That's so cool.
It's set up like a gimbal,
A gimbal.
which is basically a set of rings that let an object rotate freely
Oh, like in any direction?
in any direction.
Interesting.
You can think of it like a fancy multi-directional swivel,
Okay, why is that so important for understanding flight, though?
because it helps us see how all these rotations
Okay.
interact with each other.
Ah.
The simulation has this really cool feature
What is it?
where you can adjust each rotation individually.
Oh, wow.
So you can do pitch, roll, yaw.
All separately.
Yeah, so it's like you can isolate each one.
That's a really cool way to learn. So it's kind of like breaking down a complex dance move into its parts.
Exactly.
Okay, and then you can put them back together.
Exactly.
Neat.
But things get really interesting when you start combining those rotations.
Okay, how so?
That's where we get into what we call coupled rotations.
Coupled rotations. Okay.
Yeah, which is where changing one axis can actually affect the others.
Really?
And sometimes this leads to something we call gimbal lock.
Gimbal lock. That sounds,
It's a tricky one.
yeah, and kind of scary.
Kind of, yeah.
If you were flying a plane, you wouldn't want that to happen.
No, you wouldn't.
So what is gimbal lock exactly?
It's kind of like, imagine you have a compass.
Okay.
You can normally tilt a compass any which way.
Yeah.
But what happens if you align that needle
Uh-huh.
with the rotating bezel?
I'm trying to picture it. So
Yeah.
the needle's pointing north, and then the bezel
Yeah.
is also set to north.
Then you suddenly can't point it in certain directions.
Really?
Yeah, it's like it gets stuck.
Oh, so instead of being able to move freely, it can only move in 2 dimensions.
Exactly.
Ah.
So that's similar to what happens with gimbal lock.
Oh, okay.
2 of the axes get aligned,
Uh-huh.
and you lose a degree of freedom.
So it gets locked
It gets locks.
into a limited range of motion.
Exactly.
Now, I've heard that gimbal lock was actually a problem during the Apollo 11 mission.
Yeah, it was a real issue.
To the moon.
Yep, they had to manually reposition the navigation platform.
Really?
Yeah, to avoid getting stuck
Wow.
in a particular orientation.
That's why understanding gimbal lock is so important.
Yeah, it's not just theoretical.
Especially for systems that need precise control.
Exactly. It can have real-world consequences.
So this simulation's not just a fun little game.
Nope.
It's a way to learn some pretty serious stuff.
It is.
But you also said it can be used for things beyond flight dynamics, too.
Absolutely.
Like
well, it's a great way to understand how gimbals work in general,
Okay.
which are used in a bunch of different technologies.
Yeah.
Gyroscopes,
Yeah.
in smartphones.
In smartphones.
Stabilizing platforms for cameras and telescopes.
Wait, so my phone has tiny little gimbals inside it.
Many of them do.
That's crazy.
Yeah, they use them for image stabilization.
Oh.
Keeps your
bro.
pictures from getting blurry.
That's pretty cool.
Yeah.
I never realized that.
It's all connected.
So playing around with this, we can actually learn more about how everyday tech works.
Exactly. It's all about the principles behind it.
That is pretty neat.
And that's just the beginning.
Really?
We haven't even gotten into the educational value for other fields,
Like what?
like mechanical engineering and computer graphics.
Oh, wow. So we're going to get into that.
We are.
All right. Well, I'm definitely ready to go deeper on that stuff.
Good.
But maybe we should give everyone a moment to catch their breath
Sure.
before we do that.
Sounds good.
We'll come back and explore all those applications.
Looking forward to it.
All right. So let's take a quick break,
Let everyone digest what we've talked about.
and we'll be back in a flash.
Back in a jiff.
So we talked about how this flight dynamics gimbal simulation can really help us understand the basics of flight.
And even some cool tech in our smartphones.
Right, but the article also mentioned that it's great for mechanical engineering and computer graphics.
Oh, definitely.
I'm kind of curious.
Yeah.
How does that all connect?
It's all about understanding how things move and rotate in 3 dimensions.
Okay.
Mechanical engineers use gimbals in all sorts of designs.
Give me an example.
Robotic arms.
Oh, yeah.
Those fancy camera stabilizers filmmakers use.
Okay.
The simulation lets them really see how those systems work.
So like a virtual prototyping tool?
Exactly.
That's
Yeah,
wow.
and for computer graphics,
Yeah.
understanding rotations is so important for realistic movement.
Yeah. In like video games,
Video games,
animated movies,
Wow.
VR.
all of that.
So gimbal lock.
Gimbal lock is a big challenge.
Is that why sometimes characters in video games kind of glitch out
It could be.
or move in weird ways?
It can cause objects to suddenly jerk or move unnaturally.
So it's like their virtual joints are getting locked up.
That's one way to think about it.
Okay, so the simulation can help avoid that.
Yeah, game developers can use this
Okay.
to understand gimbal lock.
And create more realistic movement.
Ex-
I never thought about how much math and physics goes into making video games look so smooth.
It's a lot more than people realize.
Yeah, like a whole world behind every jump and spin.
There is.
The simulation gives you a visual for all those
This
calculations.
really helps demystify the complexity.
It's like seeing behind the curtain the wizard at work.
Right.
But in this case, it's engineers and programmers.
Exactly.
Your article mentions some specific exercises to try
Oh, yeah, they're really cool.
to encourage people to go a little deeper.
They really make you think about the principles at work.
One is about figuring out what roll angle corresponds to a zero bank angle.
So when the wings are level,
Yeah, I guess that's important for pilots to know.
it's all about having that reference point.
You keep the plane flying straight.
Exactly.
There was another exercise that made me wonder,
What's that?
do these principles of pitch, roll, and yaw
Yeah.
apply to other things besides planes?
Good question.
Like, does a sailboat use them?
They do.
Really?
Though sailors might use different terms.
But the basic concepts are the same.
Exactly.
So pitch would be like the up and down motion of the bow.
Huh?
Roll is the tilting side to side.
Yes.
And yaw is turning the bow to change direction.
You got it.
That's really neat.
Yeah, it's all connected
It's like this one simulation can help you understand movement.
in so many contexts.
Yeah, not just airplanes.
It's all about the fundamentals.
And the article even challenged us to explain gimbal lock ourselves.
That's a good way to test your understanding.
Based on playing around with the simulation.
It's one thing to read a definition.
Yeah.
It's another to explain it in your own words.
It's like the difference between reading a recipe and actually cooking.
Exactly.
You learn by doing.
Hands-on experience is the best.
So this simulation is really valuable.
It gets you engaging with the concepts
Makes you think.
and experimenting to see how they actually work.
Yeah, you know what I'm curious about?
What's that?
If gimbal lock's such a problem, are engineers trying to avoid it altogether?
That's a great question.
Are there systems that don't even use gimbals?
Yeah, engineers are always innovating,
Okay.
coming up with new solutions.
So what are they doing?
One approach is redundant systems.
Okay.
So if one gimbal gets locked up, there's a backup.
So like a spare tire for your navigation system?
Exactly.
Okay.
Another approach is different types of actuators,
Actuators.
which are the things that control movement.
Okay.
So instead of gimbal rings,
Yeah.
some systems use reaction wheels.
Reaction wheels, what are those?
They spin to generate torque
Okay.
and change the orientation of a spacecraft.
So you're not physically rotating the object,
Right.
but using spinning wheels to create forces to move it.
That's the basic idea.
That's pretty cool.
It's a bit more complicated than that.
Yeah.
But the point is, engineers are always finding new ways to improve things.
Overcoming limitations.
Exactly. Like gimbal lock.
It's cool to see all the different ways to approach a problem.
It is.
There's always more than one solution if you think outside the box.
Sometimes you have to.
I'm really into this idea that understanding gimbal lock can help us design better technology.
It definitely can.
Do you have any examples of how that's actually happened?
Well, look at spacecraft navigation systems.
Yeah.
By studying the limits of gimbal-based systems,
Okay.
engineers have designed more reliable navigation,
For tougher environments.
like deep space.
Wow. So
Yeah.
those tiny gimbals in our phones,
And the huge systems in spacecraft,
they're all connected.
all based on the same principles.
That's incredible.
It just shows how understanding these concepts can lead to new tech.
It's making me realize this deep dive isn't just about airplanes.
Right.
It's about how things move
In the world around us.
and how that knowledge can be applied to so many things,
Exactly.
from video games to space travel.
It's all connected.
Which brings us to a big question.
What's that?
Why should anyone care about this?
Yeah,
What's the point of understanding all this stuff if you're not a pilot or an engineer?
that's a fair question.
I mean, it's cool to learn about, but does it really matter in everyday life?
It does.
How?
We live in a three-dimensional world.
True.
Everything's moving and rotating.
Okay.
Understanding these principles of motion helps us make sense of it all.
So it's about more than just airplanes.
Way more.
Okay, but can you give me a real-world example?
Sure, imagine you're putting together furniture.
Like from IKEA.
You have to visualize how the parts fit together,
Yeah.
how they rotate and connect,
That's spatial reasoning.
and it's connected to understanding pitch, roll, and yaw.
Oh, so that's why I struggle with IKEA instructions. But seriously, spatial reasoning is important for everyday tasks.
Absolutely.
From navigating a city to packing a suitcase.
It's about understanding how we move and interact with the world.
I see. It's not just about airplanes then.
Not at all.
It's about understanding how we move.
Exactly.
And the better we understand it.
The better we can solve problems.
And create new things.
Exactly.
So this deep dive is more than just technical knowledge.
It's about understanding our place in the world.
I like that.
But before we get too philosophical,
Right.
we still have more to cover.
Oh,
Ready to wrap up
yeah.
and leave our listener with something to think about.
Absolutely. Let's move on to the outro.
All right.
All right. So we've covered pitch, roll, and yaw.
Even tackled gimbal lock.
You know, I'm starting to feel like I could teach a physics class.
Almost.
Okay. Maybe not quite yet.
You've definitely learned a lot, though.
It's been fun. It has. But before we wrap up this deep dive,
Yeah.
I think it's time to leave our listener with a question.
To ponder.
Something to really make them think.
Okay, I like it. How about this?
Yeah.
Imagine you're an engineer.
Okay.
You're designing a brand new spacecraft.
Okay.
Knowing what you now know about gimbal lock,
Uh-huh.
how would you design the control system?
To avoid it.
Yeah, to avoid those limitations.
Ooh, that's a good one.
A challenge to all the future space explorers out there.
Exactly. We've talked about some solutions.
Redundant systems.
Yeah.
Different types of actuators.
Right. But maybe there's something even better.
There could be.
Something totally new.
It's like asking, how would you reinvent the wheel? But for spacecraft.
Would you use multiple gimbals
Maybe.
arranged in a different way?
It's possible.
Or use some kind of AI?
That could predict gimbal lock.
Yeah, and prevent it.
Those are good ideas.
It shows how understanding the problem can lead to new ideas.
Innovation.
So to our listener,
Don't worry.
we don't expect you to have all the answers.
This isn't a test.
It's about getting you to think about these concepts.
And how they can have real-world implications.
Maybe you'll come up with the next big solution to gimbal lock.
You never know.
Or maybe this will inspire you to explore some other areas of science and engineering.
There's a whole world out there.
And remember that website?
The open educational resources.
Open Source Physics at Singapore website?
That's the one.
They have tons of other simulations and resources.
It's a great resource.
This is really just the beginning.
When it comes to flight dynamics,
And so much more.
it's been great diving deep with you.
It has keep asking questions.
And never stop exploring.
That's all for today.
Until next time.
Keep those minds curious.
And those imaginations soaring.
See ya.